Thank you very much. It's really my privilege to speak with you today and to introduce this topic. And I think it highlights the increasing partnership that we're seeing between the OHDSI OMOP community and the CTSA network in the United States, as managed through the Center for Data to Health, which is the coordinating center, as well as N3C, which is its major product moving forward. The outline today is going to be some overview of the N3C, and then some obviously presentation by Hongfang Liu on the open health natural language processing environment, and some of the applications we've made in N3C, as well as the long COVID recover project. As far as N3C is concerned, the N3C is arguably the largest public HIPAA limited data set that is centralized. I fully recognize that the OMOP OHDSI community is much larger than this, but as far as let's go back. As far as a single centralized database is concerned, we have roughly 12 billion rows of data across 69 sites, over 10 million patients. And again, this is all centralized and longitudinal, with about 1,100 rows of data per patient. Next slide. Much of this work was enabled by a harmonization pipeline that we developed at the level of person, drug, procedure, and condition. It takes in many common data models, including OMOP, as well as ACT, Trinetics, and PCORNet, and we're working on a FHIR pipeline for a native FHIR implementation, although that awaits bulk FHIR. But as you can see, our target model through this pipeline is the OHDSI OMOP model. Next slide. Across the 69 sites that are currently participating, we do a little over 2 million transformations in our pipeline, and we repeat that pipeline across all 69 sites. So this is a graphical rendering in the Palantir environment of the transformation pipeline. Each little square or box is a transformation, and you can see we have high parallelization. It turns out you've seen one OMOP site as far as harmonization is concerned, and we required to have a separate analysis pipeline for each site, although we borrowed from templates for each of those. The point is we are able to harmonize the data into a single common large framework that is, I believe, unique. Next slide. And with that, I'm going to turn it over to Hongfang, who's going to tell you what you really want to know, which is the extension in terms of natural language processing. Hongfang?
Thank you for joining this community call. It's a great honor to be here to present this with Dr. Xu. A lot of you are probably aware, actually, back in 2009, Mayo and IBM released, funded the Open Health Natural Language Processing Consortium. Back then, with two systems released to the community. One is the Apache CTEX, one is the CTEX, which functions as the, get a clinical concept from the clinical notes. The other is the IBM MedCat system, which is extracting structured data from unstructured data source. And so later, the CTEX become Apache CTEX and IBM MedCat system, working on the domain of oncology domain. I'm just trying to figure out why it's not show what it is. So so this is the OHNLP. Then from 2009 to 2012 got a big boost from the ONC SharpN effort. This is effort is that kind of get, I think at that time, we have almost all the clinical NLP community to be part of the SharpN project. So that project, there we developed a data normalization framework where we have both structured and unstructured EHR data to be standardized to sharpen clinical element models, which is back then was considered to be a clinical semantic standards. And the clinical element model later become part of the FHIR effort. So you probably wonder, they SharpN have a lot of deliverables, but we didn't address one significant one, which is related to data sharing. So basically, back then, for those who are familiar with natural language processing, their significant effort was dedicated to what we call language resource development. However, language resource development require us to be able to share the data across different sites, but we all know it's quite challenging to share. And from 2013 to 2016, this was a continued effort from the sharp end, and we got luckily funded by NIGMS, R1, to continue the effort. That effort leading to three different perspectives. Look at the clinical natural language processing. One is led by University of Minnesota, Sergei Pakhamov, research on the implementability of open source clinical NLP system. A lot of you know that we do have clinical NLP system from the academic researchers in the domain, but how to implement an full actually ETL process from clinical from EHR to clinical data warehouse is not trivial. Second is led by Hua Xu from many of you very familiar with his work, which is research on the usability to deliver production-ready LMP system. The last one is actually led by me, which is mainly focused on how do we actually use NLP to accelerate and translate clinical research and practice. And from 2017 until now, we are fortunate as a community to be able to funded by an NCAS U1 grant as an innovation award, because over the years through our research, we say, okay, we are ready. We have enough confidence that we probably can help those larger community to translate, implement clinical NLP for their, clinical data warehouse. We know structured data through the OHDSI, through PCONET, through CCATS, CTSA. We got all those different structured data marks. And the unstructured part, we feel we are ready to help implement the translate. In order to achieve that, we propose to those activities, which the first goal is to try to help with algorithm development. We know the LP data sharing can be challenged. We were thought, how about summary level information, since people have no worry about sharing summary level information in publications about how many patients have this diagnosis in an institution. So we thought this could be easy done. Secondly is how do we, we know that data sharing is due to HIPAA not easy for clinical text. Can we generate a synthetic text data to be able to allow people, the public, to be able to see how clinical data looks like? Thirdly is to try to leveraging the clinical, the community, so to allow what we call privacy preserving computational phenotyping. And lastly is for the translational effort across the community. So all those research yield our current overall architecture, which we present to you today, which is the open house natural language processing, overall framework. If you look at it, we take a more informatics look at this problem and basically focus on people, technology, and process. On the people part, we do aware clinical notes, clinical documents, unlike other structured data, which may not have high risk of PHI information, but the clinical notes does record many personal related identifier information. So we were follow the OHDSI leadership in this area, which is OHDSI itself is a federated distributed data network. And we think from the natural language processing perspective, since data cannot be shared, can we have a federated NLP development evaluation for community-wide NLP collaboration? Secondly, is about the process, which we propose a trust process, which is we know that we use the data for clinical research, and the research finding can have impact for health. So we need to make sure scientific rigor and transparent are part of the process of clinical NLP. And this is involve, how we take a team science approach to tackle that, which is building trust towards the clinical NLP. Lastly, is the technology part is the empowerment. We want to take a human-centric and type of a look at this, which is basically, the things we want to build scientific literature building tools to empower clinical research community to use clinical NLP. And all those was under the foundation a right fair principle. I will get to detail later. So so when you talk about natural language processing, and this is actually one of the artificial intelligence technologies, and when we think about it, we actually needed to take a human-centric ethical AI framework to do that. Basically, there are data principle, which is more open science related data principle, which is fair, findable, accessible, interpretable, and reusable. But on the implementation side, specifically want to emphasize on the implementation side, because this is the real world data, real world evidence generation using technology. We want to make sure the things applied needed to be follow this, which called right implementation principles, which is the process need to be correct and the results need to be correct to be double sure. So this is emphasized on transparent and implementable and explainable and processable. Why we keep emphasize that? And this is a go back to the World Health Organization. When we bring technology innovation, especially AI technology, to the healthcare domain, we actually needed to truly pay attention to those different components. One is the human autonomy. Basically, how this reply, we need a human-centric approach. This is fundamentally imply we cannot truly use black box solution when we do clinical natural language processing. Secondly, it must, for the purpose of promote human well-being and the safety and the public interest, ensure transparent explainability, intelligibility, foster responsibility, accountability, and also includes equality. So that's also emphasize why we want this to be an open community collaboration. And we are hoping under this framework, the open house natural language processing overall architecture bridge nicely those two different areas. One is the academic side. A lot of those probably, in the academic side, we've been criticized for not thinking real world problems relevant. At the same time, on the industry side, we keep having technology, big technology company come to healthcare domain, but they sometimes, didn't really deliver to the level of delivery, and they found it probably it's not really kind of profitable region. So I want to emphasize on the language part. It's so interesting. Language plays a unique role in humanity and the society. When we looked at processing clinical health language, we actually needed to follow this ethical framework. And go back to the data sharing challenge. This is understandable. Basically, as a clinical peer researcher, if I wear my research hat, I want to give me the data. That's all I need. If you give me data, I can build a system for you. But on the other side, we also have this concept of data as the new oil. And basically, there are potential, pieces, but there are a lot of effort needed to creating value out of these raw data. And where P technology is a part of this potential component, which is, have potential commercial interest in this space. But in clinical research, that's a little bit different. When we use the electronic health records for research purpose, we need to ensure their methodology rigor and evaluation. So we did a methodology review implementation review about reproducibility and the methodology rigor. This is aimed to answer 5 questions. So is that how is NLP evaluation done in clinical research? What's the current reporting practice of NLP component in the traditional clinical research? What's the degree of granularity when people are reporting NLP methods and evaluation, and potential barriers for adopted clinical NLP? And not to our surprise, so we already kind of estimated. We at the end we have only 54 text article talk about actual NLP used in clinical research with some evaluation. However, the reporting standards practices is so dramatic different, high heterogeneity. We have about 58% of those articles out of 50 didn't really report how the model is defined. We have about 74 without any concept mapping interoperability. We have about 58, which is Please, the Zoom is terrible. Team, sorry. I needed to redo again, reshare again. Technology is such a barrier for me. So I couldn't see that, but this is just to show you the reproducibility and the methodology rigor in the real world data with clinical NLP used for analyze the EHR data. And most of the paper was simply say, trust me. However, it's not the paper's author's fault because there's so many evaluation challenges. For example, the most of the evaluation was mentioned, okay, they only mentioned cohort duration, but not NLP evaluation, and the EHG system migration, change of definition, ETL process changing, study setting, and the EHR environment. So basically, what is the implication of clinical research when using natural language processing techniques is that there's significant verifications because a majority of those articles was talking about getting outcomes and the risk factors from the clinical notes. If we don't have validity of the study with the rigor of the NLP methods, how can we really trust the finding? So move down to the part giving all those kind of findings we discovered. We are promoting or calling for open house natural language processing kind of a framework, which we hope is a collaborative framework for NLP development, which basically implies that yes, you cannot share data. However, can we collaborate on develop NLP algorithm and where the language part can be shared rather than the actual text data? Secondly, from this, we also develop tools and to facilitate the process, which this tool is mainly focused on the evaluation, where we have, a wide serverless type of evaluation where people can do basically creating an evaluate NLP system and to ensure that scientific rigor component. Lastly, we also try to simplify the deployment of NLP system. I mean, there are humongous heterogeneity associated with, the different EHR systems and also written for the OHDSI community. I don't want to emphasize how different local sites heterogeneity from each other. There are each one side is one side basically. But as a community, we can help each other getting the data extracted. And this minimum viable product we aim to do is that suppose you have data in your EHR, in your file system, in your relational table, we can use the standards common data model of all the OMAP standards on the NLP side, the node NLP table to transfer such a data, and then we can deploy NLP system there. Then we can get the data extracted and ingested. So this is the release 2.0. That's the current release. What we have this actually we have in this, back probably at the beginning, the release 1.0, we only have COVID signs symptoms, and through the over a year of development, we currently got a configuration and machinery incorporating into this end-to-end minimum viable product, which is you can get the COVID past relevant concepts from your EHR data. And we do have a comprehensive NLP capability for concept encoding, where all the concepts which we trained and learned from our local corpus were mapped to the OMAP concept identifiers. And we are heavily working on documentation, as any of other researchers. When you do real world implementation, documentation becomes crucial, and we are working hard on this documentation. And just a little bit of detail about the MEDLEX, which is a resource for clinical natural language processing, was funded back then through the ONC Shopping project. And this was the system, was the semantic lexicon we used for processing internally at the Mayo Clinic for indexing purpose. We keep refining over the years, and we currently have this lexicon mapped to OMAP concept. However, we are deal with the situation which we call the mapping issue between text semantics and the standard semantics. As you guys probably all very well know, that OMAP vocabulary on one terms can associate with multiple concepts. And the past resource, I want to emphasize how important as a community when you have open source practice. We didn't get from scratch for Pascal NLP. The work was many published through two different groups. One is from the N3C community, where we characterize non-COVID deep phenotypic complex condition where they have 287 concepts to be mapped to HPO terms. And we have about another one by Nigel from Harvard, which they mined from their local corpus about 355 high-level COVID symptoms, with a total about 1,500 tinted UMS concepts. So we actually combine all those two together with our original system, and we got the past mapping to OMAP concepts. And we do notice some concepts not in OMAP couldn't be mappable. Then we map to the HPO identifiers. And some preliminary work of the evaluation, we built the system. We try to see how it performs with long hauler nodes. So we use about 97 long hauler nodes at our local sites. In that refinement, we noticed 23 concepts not included in the initial Pascal dictionary, but they do have OMAP HPO terms there. And we also have terms which are not included in either of those dictionary vocabulary terminology. We didn't do thorough evaluation currently because creating gold standard for evolving domain can be quite challenging. A lot of you probably aware. So we did try to compare how human doing with the computer, with the NLP system. So we have a one human annotator 30 nodes with the past symptom section, and we run our system on the same symptom sections and try to compare the two human with the machine. And so we, among the 1,500 combined concept mentions, we notice there are about 100 was annotated by both. But we noticed for the there are 414 was only annotated by P, but not a human. Some are obvious human emissions. Some are human was leveraging their contextual inference there. Basically, this is the patient before COVID, they have this history, and we don't consider they are part of the past, but we all know probably that's also part of the past too. Anyway, so we also have 62 annotated by human, but missed by RP system. Among them, we noticed 48 of those unique annotations were not in either OMAP or the HPO. and the remaining were caused by lexical variants was not recognized by the engine. So I talk about the PASC system, and we are calling for join the journey for our NLP empowered recover. Is Emily here? So I was going to briefly talk.
I'm here, Hongfang. I'm sorry, I had trouble getting off of mute. Yes, I am here.
So from Zoom to Team is so hard for us. Okay, go ahead.
So this is a flowchart that we put together, and when I say we, I mean the N3C phenotype and data acquisition team, late last year to sort of give sites an idea of the real practicalities of submitting the extracted NLP data. And again, as Hongfang mentioned, it's summary data, not the full notes themselves, to the N3C enclave. And so this flowchart is really designed to handle all of the different scenarios that you may find yourself in at your site. We know that your N3C data is more than likely in a CDM or common data model that is not in the same place as where your notes live. That's just a fact that is true at many of our sites, and certainly my own site. And so we have this flowchart to sort of dictate, all right, if your notes are not in the same place as your CDM, here's what you need to do in order to get the table to a place where we can then pick it up with our N3C extract scripts, which if you're already an N3C site, you are used to using to submit the rest of your data. There is on the same page, and I will put a link in the chat when I am finished talking through this slide, but there is much more detail about what these steps entail and where you can go for questions or concerns that you may have. But this wiki page does provide sort of the basic overview of how to get data from your notes through the process that Hongfang just laid out to N3C for use in various research studies. Excellent.
Wonderful, thank you.
Sure.
So as we so this is the when you ask an academic researcher to help with the real world dissemination. So we quickly assemble a team here helping with sites onboarding. So we do like to meet individuals, sites who are interested to deploy the system. So those are for those who are interested in deploying the infrastructure. There's a contact there. But since the slides will be shared, you will be getting those names. And for any other question, you can reach out to me. However, there are planned development currently ongoing. So one is that for those who are in using Trinex for their structured data, we are fortunate to have the partnership from Trinex to be able to deploy the NLP engine to be part of the Trinex appliance. The work is currently ongoing. We are going through the security checking from the Trinex side to make sure the software can be run on the Trinex appliance. And we are actively working on NLP knowledge authoring and concept mapping service empowered by terminology service and large language models. We generally, when we take the human-centric approach to do natural language processing, we do take advantage of the statistical natural language processing techniques to help us to do the knowledge engineering and the knowledge authoring. And I think this actually, the more I read about OMAP OHDSI concepts mapping side, we're probably going to looking for collaboration here. And lastly, we have many kind of open source NLP systems available for releasing. So we will work getting those to be part of the OHDSI default release. Here this including family history, which has been a long, clinical NLP task by the community. Second is genetic information in the clinical notes. Third is the contextual classifier for clinical NLP. A lot of times, what the end user need is a contextual semantic passing, which is generally is the AI hard problem, but under the clinical domain, we think we have a way to mitigate that. leveraging the standardization down in the clinical documentation standards community. Of course, precision oncology is really require a lot of concepts not captured structurally, which RP can come to play. Lastly, non-nested social determinant of health variables. This is a really, really hard problem for our clinical RP community because both the standards and the text part are not well evolving in that, but we know for the real world data parts, the social determinant of health pieces is a big topic. And we call for ongoing community collaboration. So we do, if you have open source tools and resource, I would like us to be OHRP as the implementation delivery vehicle. We like to you to join our journey. Because as I said, it's no longer a technical problem. It's more a community and a process and the real world translation problem now. We want to emphasize is that there's due to the heterogeneity of the clinical documentation, due to the evolving knowledge about the domain, there is no perfect solution out of the box, and it's require a continued refinement and evaluation, just like any other knowledge authoring kind of practice, including, for example, all the phenotyping in OHDSI side, we go through that whole same process of consensus and team collaboration. We also like to call for collaboration related to context classification. We didn't feel this was a problem when I only involved with single site study because we adopt very good documentation standards, but as soon as you go to multiple sites, it's become a kind of like what those kind of like things, but we do believe we have a solution to resolve that, leverage the technology we have currently. Lastly, this is data quality and machine learning. This is a general, not just recover and 3C, but I believe across almost all the OMAP and OHDSI sites, we do see the RP, adding RP to the data mart itself may impact the distribution of the data and impact the data quality and may change the research finding. And how do we ensure we can correctly leverage the RP data in those situations? The reason I mention this is because clinical notes document events does not translate that events happen at the time of that documentation. It may be some events happen, previously, or maybe something happened, from other places, and the temporal perspective of the RP is actually a very hard problem, and how to use that, leveraging that require contextual information. And so this is our last slide. And basically, just like OMAP OHDSI community, we do like, this is not possible without the community support, without the funding from National Institute of Health, and also all the previous funding potential make it possible. And lastly, we do like the tagline, join the journey. So we want to call for join the journey to translating technology innovation to empower clinical research and towards better health for everyone. So I think that's the last slide. I stop here. Sorry for the technical glitch. I'm familiar with Zoom, but not familiar with Team.
That's okay. Thank you so much for this great presentation. So we have about 10 minutes for some questions. So I'm going to ask people to raise hands, and I'll call on them as we go. We also have a lot of stuff in the chat, and I know Jose had a number of questions, and it seemed like some were answered. But Jose, if there's something specific you wanted to ask that maybe wasn't answered first. And also, I believe Wei had a question early on. But Jose,
Sure.
is there...
Sure, I'm here. Thank you for the presentation, Dr. Hongfang. Really great job and very difficult work to do in such a heterogeneous environment. So, how are you? What are the current plans to scale up the NLP pipelines inside the Palantir environment? Since I know that's sort of a big challenge, right? Because sometimes it can take seconds, right, to process a single node. So, what are the current plans to make that happen?
So the Palantir, so the processing, this is a federated deployed environment. So we are not really call for sites to get their documents to be in the data enclave, but we are giving you so I probably don't have the slide. So the minimum viable product, so we take advantage of two parallel processing techniques, the big data techniques. One is the Apache Beam, one is Apache Flink. Those are helping parallelize speed up. And the current speed, at least our local institutions implementation, I can tell you the speed for running our enterprise data warehouse with 300 million documents. It takes us about 48 hours to processing all the documents. And the technology, MedTarget, the dictionary lookup engine there, was to take advantage of which we call a Hakoric algorithm, but not in the traditional sense. So we did that implementation, taking the words as the alphabet and implement it in that way. So it's very, very fast, but it's a little bit resource intensive regarding memory, because instead of 26 characters for alphabet, we are using all the words as alphabet. And I see someone ask, do we use specialized lexicon? Yes, we use specialized lexicon to help normalize the lexicon variants. And thank you for to provide that, because that's make it possible.
Thank you. I'm sure we would love to hear more about that implementation in Mayo here in the OHDSI community. So thank you very much.
Sure. Andrew, yes.
Yeah, I wanted to thank you so much for the presentation, and I want to just note a couple of things. So we were one of the test sites for the NLP backbone that Hongfang's group developed, and I think it's worth mentioning how easy it is to deploy and how performant it is when you run it at a local site. And so it's a challenge to do this work well, having all of the IT pieces in place in a containerized form, along with a community that knows the best practices for local annotation and validation of algorithms to make sure that they're both clinically valid and performant makes doing this work at a high level across a community feasible. And that's really a significant feat. I also want to mention the N3C itself is free. Chris's overview was excellent. It didn't mention that anybody and everybody around the world, citizen scientists to anybody, can use it. The fantastic work done to ingest data and harmonize it by all of the folks involved has resulted, as Chris pointed out, in nearly 70 institutions' data in OMOP form. And this community, the OHDSI community, is really in the best position to leverage that for research. So you can come in without anything other than an ask to do so and start doing research as long as it's COVID related. It's also a really formidable achievement and an extension of the OHDSI community, and it really adheres is an absolute twin in terms of its commitment to open science and participation, and it's worth noting that. I think the other thing to note is that we're on the finishing touches of the user acceptance testing for the OHDSI tool stack being there. And so being able to just run OHDSI studies as they are meant to be written in that environment is near at hand, and people are invited to do that. But yeah, Hongfang's entire team has been a pleasure to work with, and it's embraces all of the same spirit of community development and open science that we enjoy in the OHDSI community.
I do want to emphasize that. Thank you, Andrew. That was actually quite gratifying. But I do want to emphasize that the N3C is a centralized resource, and in that context, whether federated or centralized is better or worse. Emily Pfaff just wrote a very illuminating paper on that with many other N3C authors. And I think we decided that it's really a synergy, that you need locally curated resources and that they can contribute to a centralized resource, and that the opportunity for centralized quality, data quality review and benchmarking in a centralized resource at scale is worth the advantage, not to mention the opportunities for inferencing. The NLP adjunct, I want to emphasize, as Hongfang said and Andrew implied, is really a federated component of this, as is the creation of the original common data model to send to N3C. We will integrate the ontological annotated bits, if you will, that are extracted from NLP into the central resource. But there are no clinical notes sent to the central resource at any time. The NLP processing, I must emphasize, remains behind a firewall. Many organizations, Hopkins being one of them, consider that getting a bit of an echo. Consider that clinical notes are in fact PHI, that efforts to de-identify them notwithstanding, many organizations will not share clinical notes in an open forum. And thus the importance of having distributed federated NLP that can extract the good bits, if you will, relevant to COVID or recover a PASC or whatever the use case might be, and then integrating those into the common data model like OMOP is really, I think, the heart of this activity.
Yeah, I think I want to add one more thing, because the OHRP, what we emphasize is more federated development evaluation, but we do want more centralized knowledge, LP knowledge, development, because in that way you can promote an open collaborative environment, because we cannot challenge a legal hurdle and patient privacy type of concern. However, as a researcher, we can share just how OHDSI community achieved. It's like sharing how to do the ETL, the knowledge about it. That's the informatics knowledge about it. So, and it's wonderful. And I think we're taking OHRP as a hybrid of both. Not force people to give me data, but let's work as a community to share knowledge, share best practice, and contribute to the real world data journey.
Wei,
collaboration,
I think. Hold on, Andrew. Wei, you had mentioned something in the chat. I wanted to give you a chance if you wanted to ask your question.
Yeah, this is Wei from Vanderbilt. I think this is great. Just a quick question. I think Chris already mentioned lots of the answers. Quick question is how frequently you update the NLP table?
How frequently you update the NLP table? Right. You mean in the N3C side, or you mean
the N3C side?
So the N3C LP currently the table is not exposed for, because we only have 4 sites, right? If I'm not mistaken, it's the 4 sites finish the ingestion side, but we hope through this more OHDSI community members who also contributed to N3C can contribute more data, because 4 sites, so there's a potential risk of site identification. So we didn't really expose as a part of the N3C enclave data set.
And I'll just add to that in terms of as a site, how often you should update your table, that's whether or not that was the question you were asking. It's an interesting thing to point out, because that's something that many of us early adopters are also pondering. And I think that we are open to what works for your site, within reason. Obviously, if you tell us you're going to update once a year, that's not so workable. But as we know that processing power is at a premium, if you can update weekly, great. If you can update monthly, great. Just reach out to us and we can be more than happy to negotiate that frequency.
Yeah, I think it depends on the cohort, right? When we do submission, it's aligned with your N3C cohort. So your submission, so basically, I do think the contents of the LP table will keep changing because of the table, your cohort need to be consistent, but at the same time, the algorithm updates the frequency. That depends on, the community needs. Do we need to add more NLP algorithm there, or, that's for all the sites who want to contribute, that would be great. So.
I know we've hit the top of the hour. If you do have time for one more question, I know Christoph raised his hand a minute or two ago. So Christoph, let's you can conclude this session. Yep, go ahead.
The mic.
I'm sorry.
There you go.
Great work, Hongfang. I know last time I got an overview with you, there was a lot of the effort was you really sort of focus on defining a specific phenotype or cluster of terms. You validated very kind of resource intensive effort in terms of human effort to curate, review, and validate, right?
Yeah.
Is there some parallel effort to just sort of distill the presence or absence, and maybe with some sequence of just all the terms and their negation, so that machine learning and other algorithms could just take advantage of that? And is that workable within the OMOP framework?
Yes. We have a resource built for that. So the whole, so basically it depends on where you want to do. If for the clinical research itself, we need that, but for big data practice, we have the resource available for the big, all the general, we view general clinical NLP concept indexing. So we have the resource mapped to OMOP concept now, and we have that. It's just
so you have that now, like you just tag
we just
everything.
Don't include as a default release because it depends on your local site's infrastructure. Remember, each token will change to a concept in your table, and it require the resource needed to enable that. But we have the resource for people for sites interest to run that. We have that.
Okay.
Yeah.
Thank you.
It's just in the current 2.0 release. So we didn't expose that before because we were thinking at the end of the day, for clinical research, you still needed to do engineering, the knowledge engineering as the end user, clinical research phenotype side.
Thank you.
All right, thank you again to Hongfang Liu, Christopher Chute, and Emily Pfaff for this great presentation. We will have the recording posted on the community calls page later, as well as the team site. We'll have the slides as well. I know a couple of them got cut off a little at the bottom, so we'll have those available later today. Thank you, everybody, for joining today. Have a great week. We'll see you next week for the start of Phenotype February.
Sounds good. I will do a recording myself so that those slides will be available in a more complete version. Sorry about that.
Yeah, that was wonderful. Thank you so much for all your work in this and your leadership. Have a great day, everyone.
Bye-bye.
Bye.